When it comes to developing jump features, John Saul, our next speaker, has an interesting way of thinking about how we prioritize. We do have to prioritize which features we want to invest in. So how do we think about what's most important? Are features that make our product more powerful what we should work on? How about features that make it more attractive or sexier? Or features that focus on pain relief, easing the burden of analysis? Well, John thinks that pain relief should be the main motivator for our R&D team. John is the co-founder of SAS. He's the lead architect of JUMP, which he founded more than 30 years ago, for scientists and engineers who have data and need a way to explore it easily, visually on the desktop. He's going to talk about the driving forces behind JUMP development and the ways that we come across features we want to work on. So with that, I'd like to welcome you, John. Thank you.
Thank you, Jeff. And here we are live from the new Digital Conference Center in Cary, North Carolina, where we can fit a lot more people. So let's dim the lights a little. Well, I'm not really here in the Digital Conference Center. I'm really at home, so I got a home office. Whoops, not that one. Like all of us, I'm at home delivering this conference, but let's switch to a corporate background and get started. So what shall I talk about? Well, when we have JUMP releases, on those years that the conference aligns along JUMP releases, that's what we talk about. But on the alternate years, I always just pick a topic. So I picked big statistics one year, or ghost data the next year, or secret features 2 years ago. Today, my topic is big words that start with the letter A. Well, these are words that characterize themes for developing JUMP. So let me share my screen and let me minimize. Here, share. So, which theme is most important? And here are the three words that start, the big words that start with the letter A that Jeff just mentioned. First is anabolic. Well, anabolic is all about growing muscle, making JUMP more powerful. Anabolic processes build organs and tissues, and these processes produce growth and differentiation of cells to increase body size. So increasing the power of JUMP would be the opportunity, and that's, of course, very important. But the next A word is also important, aphrodisiac, making JUMP more sexy, more exciting, the thrill of discovery. So we want that to be an attribute too. But we also care about your progress during the work stream. So analgesic is the third word, and that means pain relief. Make the product less frustrating to use, less burdensome, so you keep more in flow. So which among these three themes is the most important? And so the winner is analgesic, pain relief. So I want people to express things like the following imaginary quotes. Version 15 has just saved me hours or even days of work that I used to have to labor over. That's a lot of pain relief. Or I used to have to do each one individually, and now it is all in one swoop. A lot of pain relief there. Or I used to have to use several other tools to get everything done, but now I can do everything in JUMP. Or I showed my colleagues how I did it so easily and they were amazed. Or I used to have to program all this manually and now it's just a few mouse clicks and it's done. Or JUMP keeps me in flow, keeping my attention on analyzing the data rather than diverting it too much to operational details. These are the expressions of pain relief that we want to hear. Now, why? Well, pain and frustration are real demotivators. Flow is important. You're undistracted when in flow. When in flow, you're more likely to learn something from the data and make discoveries. Now, power is important too, but new features tend to be used by only a few and old features by many. So we want to make the old features work better to reduce the pain in using them. And of course, productivity is hugely dependent on how effective our tools are with respect to the use of time. So if we can make it easier and faster to get to the results, that is a huge win. So let's go through a lot of examples. First, the scripts that come with the data tables. So here you see side by side an example from an earlier release of JMP. I think it's JMP 14 or 13, where you used to have to hold down the mouse key on this button, and then it brought up a menu item, and then you found a run button to run that script. But the new way just has a play button right next to the script. And so you just click on that play button and it saves pulling down a menu. Well, that's not a huge win. You think that just the difference between clicking a button and pulling down a menu is not very much. But it's also a big win for new users, because new users no longer have to understand that a hot button will have a run under it, but there's the play button right there with the script. And so there's a more understanding that these are scripts. And the ability to store scripts with your data is a big deal in JMP, and we want people to learn that right away and not have to fish around or look at a tip to learn that that's the way it does. And it's a great convenience to be able to store all your scripts in the data table itself and not find other places to store them. So for new users, the play button. So that is some pain relief just in that simple change. And this is a change that we regret not making much earlier in JMP. Let's talk about preparing data. And one of the big things that you have to do when you prepare data is join data from multiple sources. Now, JMP, even from version 1, had a join utility, but this still involves complex dialogue and working with multiple data tables. So here's the classic example where I'm renting movies, and we have our movie rentals transaction table that has the customer, the item number, the order date, the order year. And then we have our inventory of movies to rent, details about each movie. And then we have the customers, information about the customers, and so on. And we want to ask questions that involve all three tables, like which genders are prevalent in which genres of movie. Well, that involves going across all three tables. And of course, the join command is the way to do it. I take the transactions data and I merge it with customers. And of course, customer ID is the matching column. And I want to include the non-matches from the transaction side. So if I don't have customer data, I still won't lose my transaction data. And that's called the left outer join. And so that makes the new data table. And now to that data table, I want to join that to the inventory data. So I join that by the item number, which I match then, and that I also want a left outer join. And now I have another table. And so now instead of having 3 tables, I have 5 tables, the results of that join. But now I can look at answering the question of gender by genre, of which gender tends to be rent more on which type of movie. And involved making all these new intermediate data tables as well. It turns out that there's a lot easier way to go, and the pain of just these extra steps and extra tables can be vastly reduced. So let me undo this table on this table. And I want to point out under the tables command, there is a command called JMP Query Builder. And this brings up the SQL facility for joining tables that's much easier than all those join dialogues, but it still also makes the new data table. But a couple releases ago, we came out with something even better that reduced the pain even further, and that's virtual join. So if I look at this transaction table, I notice that it's already joined. So what's happened is that when I've prepared the movie inventory table, it's uniquely identified by item number. And so I give item number then a link ID saying it's uniquely identified by that. And that's the way I can index that table. And similarly, I have an item ID to identify the customer data. And when I prepare my transaction data, I have these two have, in a sense, foreign keys, a link reference, and it's referencing a different data table by the identifying ID across them. And so it automatically links it, and I already have everything I need to answer that question. So I can do, for each gender, I can find the genre of the movie I want to do. And so I can see here, with, action movies are like more by the males, and family movies by the females, and rom-coms more by the females, and so on. So I've answered my question involving 3 tables without the need of going through all the joins, because it's virtually joined by matching up those ID columns across the tables. So I've made a lot of pain relief from that. So let's close that. In fact, so data table joining has involved, I think, a lot of pain relief over our releases. Recoding. That's one of the main other things we do when we're preparing data sets. We started with a very simple recode many releases ago, where we just had a field for the old value and the new value. And the new value was started out with the same as the old value, and then I can cut and paste or edit those values in order to recode into a new column or the existing column. And Recode, every release has gone through dramatic improvements, and we're very excited with the current state of that. And so let's look at this data set of hospitals, district hospitals. And now Recode is right on the right button or right click menu in the column header. And I can go through and just select a bunch of things and group them to new value, like clinic. But there are lots of shortcuts as well. And one of my favorite shortcuts is to group similar values. And so I can give some threshold of the number of character differences and so on. And it will automatically group all those things. So it'll group all the district hospitals with slightly different spellings into one. And I can still, looks like it missed one, but it's okay. I can now group that one with the others. And all the rural hospitals have been automatically grouped by those matching. And it looks like I can match an extra one here. And now all of a sudden I have something, I've saved a lot of effort in doing all that recoding. And of course in JMP 15, we added new features, which I won't show here, but I want to point it out. If you have another data set with all the approved, the best category names for those categories, I can go through a matching process and have it choose the closest match when it finds a match to all those things. So, so Recode has gone through a lot of evolution over the releases to reduce the pain in that operation. And of course, think about it. How much time do we spend preparing the data versus analyzing it? Often it's anywhere from 70 to 90% of our time is spent preparing the data. And so reducing the pain of that and reducing the time of that become major wins. So pain relief on recoding. Clicking on values. Here's the city's data set. And let's suppose when I'm looking at the details for some of these things, like it might be an outlier for something, I want to look at it in greater detail. And so I can turn that into a link. So let's turn it into a wiki page, Wikimedia page thing. I'm going to copy that text there and go to column info, and then turn that into a link, which is the expression handler. And now I can take this table and convert it into a web address. So and I'm going to go to wikipedia.org and then take the name of that city and change it to title case. And I can test it on that row, and it brings up Albany. And so now I'll say, oh, okay. And now I can click on any city and then get the Wikipedia article on that city. Or I can change it to map coordinates. So I can, let's copy that text and go to the column info. And now instead of that, I'll do title case on that. Let's see if that parses okay. And now I can click on Denver and it will query Denver in the Google Maps. Okay, so I've made things into links that can do searches, can do map requests, and so on. I can even paste this speak into it and click on that and have it speak the name of the city. And so this, I think, gives great power to be able to store links in our data tables that link out to web pages or do other things. Anything you can express with JCL, you can do with those event handlers. So that can reduce a lot of pain. So one of my favorite pain reduction techniques is broadcasting. And this is where you hold down the command key or the control key to do multiples where you have a lot of analyses that are similar, okay? So this works not just for menu commands, but for many buttons and for resizing graph frames and doing other things, pasting things into graphs and so on. So let's do an example of that. And let's click on, or just do a distribution on all these columns. And let's say I wanted to get rid of this box plot. And if I just held down that menu item, I would eliminate the box plot for that item. But what I want to do is eliminate the box plot for all items. So what I'm going to do is hold down the command key and uncheck the box plot. And now it's unchecked for all those things. I can now uncheck the quantiles and it will uncheck for everything because it has taken that command and broadcast it to all the active objects in that window. And for those active objects that understand that command, the quantiles command, for example, it will then obey that command. Now that even works for some things that have to do with prompting dialogues. So let's look at summary statistics. Let me hold down the command key and customize summary statistics. And let's say I don't want the confidence limits, but I do want the number of missing values. And I'll say, okay, and it's going to apply that to all the things. And in order to do that, it's had to take the results of that dialogue, make a script out of it, and then broadcast that script to all the other places in that window. Now, that doesn't happen all the time. Sometimes when you get a prompt, you'll get a prompt for every analysis. But every release, we try to implement a few more details where the dialogue is done before the broadcast, so it'll broadcast the same dialogue to every place available. And of course, everything else, I can broadcast a change and it will change the size of all these items. Or I can broadcast changing the background color. And I can change all the background colors to orange in all the plots that seem relevant for that frame box. So this broadcasting becomes a very powerful tool. So that has saved a lot of pain for most of us. But there's still cases where you may have 40,000 buy groups, as came in earlier this year, and you want to do an inverse prediction on all 40,000, and it prompts you 40,000 times. That will be fixed for version 16. That is a lot of pain relief for that one user. Saving formula columns. I love formula columns. When you fit a model, you can save a column of predictions, but in that prediction, there's a live formula so that you can examine that formula, you can modify it, you can apply it to new data that comes in, you can profile it through the saved formula. You can, if you have Jump Pro, you can go to the Formula Depot and do a lot of other things. You can generate code from it and so on. So the ability to save formulas is an important thing. But sometimes if you have buy groups, for example, saving formulas has a lot of extra subtlety. For example, let's fit, this is the diabetes data where we fit the response against all these predictors, but we want to do it separately for each gender. So let's do that. And so we have two buy groups for gender 1 and gender 2. And now let's say we want to save the predicted value, in fact, for both of these. Now, in the old days, before we subjected this to a lot of pain relief methods, what would happen when you saved it, it would go to a local data table. If you look in the data table window under redo, it shows the by group table. So really for gender equal 1, there's 235 in this virtual data table here, which you can show for gender equal 1. There's a table variable here that shows the by group for it. And it would save it to this temporary table instead of the real table that you have that is really saved. But some time ago, when you save the prediction formula, we save it to the real data table. And if I look at this, I just saved it for gender equal 1. And if I look at the formula for that, it shows that if gender equal 1, that was the by group clause, then it has this linear combination that forms a prediction for that variable. And then if I then do gender equal 2, or if I held down the command key to broadcast prediction formula, now it has both of them, and I have both clauses available for gender 1 and gender 2. So it's adding a clause each time to that output by group. By the way, the same thing happens when you save other things. When I save a column of residuals, and let's hold down the command key this time, if I save a column of residuals, it will save it for each by group. It will save the residual appropriate for that by group. It's as if you subtracted predicted formula from the original response, but this time without being a formula column. In almost all places in JMP, we haven't done it everywhere, but we've done it in most places, saving into a by group, or in some cases through a where clause, will then save it to the original data table with the condition, the if statement. Okay, so that has saved a lot of effort. If that hadn't been available, it would have saved it in a temporary table, and then you'd have to cut and paste that formula and make if tables to the original table. So we've solved these problems. Now, let's suppose I saved it again, did that whole process again. And did another thing, say with different variables, some of them removed, and now saved it again. So I saved prediction formula, this time holding down the broadcast key. It's actually making a new one instead of saving it into the old one. And it appends a 2 after it. Well, how does it know not to save it into the old one? Well, each fit has an ID to it. And if I look at the properties by ID, it has a number to it, a unique number, which is regenerated for each fit. And so as long as it has a different by ID, the different by groups will have the same ID with one by partition. But as long as it has the same by ID, it will save it into the same thing. Otherwise, it will make a new place to form to save it. Also, whenever we save predicted values, especially prediction formulas, it will create a attribute, the creator, and in some cases other information. In this case, it has the target variable y, that's what it's predicting, and the creator fit least squares. And then when you do other platforms, such as if you have JMP Pro model comparison, then that model comparison will understand which predicted values referring to which creator and which target. And so it can keep track of all that information for those added value platforms. So formula columns work by adding new clauses, and other properties are used, including the by ID and the prediction clauses. If you saved into categorical variables, it saves a whole range of variables to have the probabilities for each response level. And all that is contained with all the metadata it needs. And that should save a lot of pain. So let's do another example of saving some pain. Removing effects from models. Well, let's look at an example of fitting, just fitting height by weight. Well, here's an example of a high degree polynomial. This is a 7th order polynomial that fits better than a 6th order polynomial and so on, but would you trust that fit? It turns out that if you give the model a lot of flexibility by introducing high polynomial terms or just by introducing more variables, it gives a lot more opportunities for it to fit. And in this case, it's allowed the flexibility to make a deep dive between the previous data and the last data point just to fit that last data point better. And so it's overfitting. It's using that parameter to fit noise instead of fitting the data itself. And so overfitting is a problem anytime you have big models. So you want to fit the signal, not the noise. Okay. Large models tend to introduce more variation into the prediction because the prediction, after all, is a function of the y variable they're using, but also that y variable is a systematic part of that variable plus the error part of that variable. And if that part is random, then your prediction involves that randomness. And if you allow it too much flexibility, it's going to end up with an overfit problem that you're going to predict much worse by including all the variables in that model. So the cure for that is to shrink the model, to reduce the size of the model or reduce the size of the coefficients of the model so that less of that variation from the random term of the model is transmitted into the predicted value. And so with small DOE problems, this is not an issue because the data is small and the data is well balanced to fit exactly what model you're going for. But for observational data and any large models, overfitting is a real problem. So users often didn't appreciate that until we introduced cross-validation in JMP Pro. So if you have JMP Pro, you can set up a validation column which will hold back some of the data in order to estimate the error on that holdback data set. And here's an example where I'm trying to predict the concrete properties depending on all these ingredients in the concrete, and I have a huge model for it. And if I just run that model, but hold back some of the data and look at the R-square on that, for slump, I have a great fit. I have an R-square of 79. But on the validation set, I have an R-square that's negative. Any R-square that's negative means it fits worse than just fitting the mean. So if I fit the mean, I'd have an R-square of 0. If I fit this whole model, I have an R-square much worse than that. So with large models, you can go worse than just fitting the mean. It's worse than, it's kind of anti-informative because the model is so big and we've had no effort in cutting down the size of the model. The model has been dominated by the noise and not the signal. So this is a problem that you should pay attention to. So the important part is to be able to reduce the size of the model. And now we did introduce a model dialog command to do that. And let's go into the diabetes with a model. I can run this model, and if let's say I want to take out a lot of these things are not very significant. You know, age has a totally non-significant contribution to the model, and so I want to eliminate age. Well, then I could go back to fit model and recall it, and then eliminate age. Or I can just go back to the model dialog directly here and fit age and remove it. But I may have a long list of models here, and going back and forth to do these things is a fair amount of work. And so rather than do that, let's see, what am I doing here? Several releases ago, we introduced a new report called Effects Summary. And with Effects Summary, it makes it trivially easy to subset the model to make it predict better, give it less flexibility. So I can say, well, age, I can remove that. Or, well, there's lots of variables. Let's remove 3 more. LDL, well, that looks more significant. And so I can save that model. Let's just save it to the data table. And I come back later and say, well, let me remember that model. It has this. I can actually undo the previous thing. And so I can undo that, and it brings back 3 of the variables. And I can undo that, and it brings back age. So it actually stores, when I use the effects summary to edit the model, it actually stores a memory of all those things. And if I look at that script, I can see this history thing. So every time I did effect model, it's storing a clause of history. And when I do the undos, it's undoing it back to that history. So removing is easy. I can also add things. If I subtracted these 2 things, I could add it back. I could add back, say, age. Not a good thing to do, but I can do it. I can also edit the model by bringing back a small version of the model thing and of the model dialog to edit compound effects and so on. Now, another thing that happens with large models, and let me undo this. With large models, you're doing a lot of hypotheses tests. So if you have a large number of hypotheses tests, there's some adjustments that you should consider. And one of them is called the false discovery rate. And so instead of treating all these p-values as if they were independent tests, I want to apply an adjustment so that those p-values are adjusted for the multiple test bias, for the selection bias involved in subsetting the model. And so I can apply a false discovery rate correction to it. So instead of the regular p-value, I have the false discovery adjusted p-value for that. And now I'm being more realistic. So this is going to help me with the overfitting problem and the hypothesis, the selection bias problem in doing a lot of multiple test things. So now let's do the next topic, and that's transforms. Suppose you want to do a model, but instead of y, you want to fit the log of y. Well, before, what you would do is create a new column in the data set. Log y. And then for log y, you'd specify a, let me do a formula. And I can take the log of it. And now I can go back to my model specification and do that log y. And then I got my fit. Oh, it's missing. What did I do? Forgot to enter the objective, the argument. And so now I can fit the log of y. And now I've done it, but let's do the profiler. My profiler is in terms of the log of y. Let me save the predicted value. My prediction formula is in terms of the log of y. And now I'm going to have to go and hand edit that, that formula and take the exponential of that to bring it back on the original scale. So that's a lot of pain doing transforms that way. Well, several releases ago, we introduced transforms. So I can take that transform and transform it to the log, and now use it directly there as a transform. And it's not part of the data table. It's a virtual variable with a formula, but not added to the data table. And now I can fit my model to the log y. Let's remove age so it fits a little better. Whoops, I had that selected too. And now I've fit the response log y. So if I profile that, what do I get? Factor profiling profiler. Instead of profiling the log of y, it profiles y. The profiler looks at that as a transform and says, well, I can invert that transform and go back to the original scale. And that's what it does. It back transforms through the log of y to take the prediction and put it on the original scale. And it will do that for most transforms that it can unwind. If a transform involves multiple variables and so on, it can't do it, and it will just do the transform instead of the original. Same thing when I save a column. When I save the prediction formula, it saves a prediction formula on the scale of y rather than the log of y. And so these things are incredibly time-saving and saves a lot of effort in using transforms. So there's, well, let me go through diabetes again and consider another transform. When you're doing variables, there's a Box-Cox transformation that you can get. And among the factor profiling, the Box-Cox option tells you if you transformed a whole range of power functions, what would be the best to do? Should it be just untransformed? That would be a Box-Cox lambda value of 1. If you did 0, that would be equivalent to taking a log of it. If you did -1, that would be equivalent to taking the reciprocal of it, the power to the -1. If you did around 0.5, that would be equivalent to taking the square root of that. And it's telling you that this model would fit better on a transform scale adjusted for that transform if it was more along the square root transformation where lambda was 0.453. That's the optimal value in that Box-Cox transformation. And you can zoom in on this with a magnifier to get it more precisely. So, so now I can transform, and several releases ago, I added several columns. One is refit with transform, which will make a new window with the transform response, and another is replace with transform. And I'm going to do that, and rather than 0.53, I'm going to just take the square root transformation, 0.5, and now I fit the model with that transform. And now lambda best is around 1, which is where it should be because it's already transformed at once by a Box-Cox transformation. And now I can save the predicted value of that and profile it and so on. And I can even undo it. So if I don't like that transform, I want to go back to the original, I can go back to the original and it refits. So we've done a lot of pain saving in transforming responses. So now there's a special place of pain when you have a lot of data. And we've gone to a lot of effort to try to solve big problems with less pain. Whether you have lots of rows, lots of columns, lots of groups, many models to try. In today's world, we live in a world of big data with big problems. So if we have analyses that were originally designed to handle small problems, it may not be appropriate for large ones. And the central problem with big problems is that there's just too much output to sort through. If I'm fitting the same model to 1,000 variables, I have 1,000 reports to sort through. If I'm looking for outliers among 1,000 columns, there's just outliers, separate reports for each column and so on. I want to be able to more efficiently get through a lot of large data sets. So we developed the screening menu, which is meant to solve these large kinds of problems. And plus, there are lots of places throughout JMP that solve large problems better as well. For example, time series. The new time series forecast platform will forecast many time series instead of just one. So the items on the screening platform: explore outliers, explore missing values, explore patterns. These are for doing checks of data. And then things looking for associations, response screening, process screening, predictor screening, and of course, time series forecast is the new item. It's not in the screening menu, but it's organized for handling large problems. And all these things take advantage not just of more compact ways to represent the results, so you don't have to look through thousands of reports, but they're also computationally efficient. They use multi-threading, so that takes advantage of your the multiple cores in your CPU to make it very fast. So let's say you got a lot of process data. You have 568 variables. So which of these variables looks healthy? Well, process screening is designed to answer that. And so it can sort by the stability or sort by the capability, PPK, or which ones are bad off, or sort by control chart measures, out of control counts, and so on. But what's I even like better are some of the tools that show all the processes in one graph, and there's two of them that I love. One is the goal plot that shows how each process behaves with respect to the spec limits. And if it's a capable process, it's in this green zone here. If it's marginal, it's in the yellow zone. If it's not, it's in the red zone. And if it's high up, it has too much variance. If it's to the one side or the other, then there's a problem with it's off center, it's off target. But if it's in the green zone, then it's a good process. And with version 15, we introduced the graphlets, the hover help, so that you can see each process as you hover over it. And then the other plot that I love in summarizing all these things and reducing the pain of looking through all these reports is this process performance graph. So on the vertical axis, it tells you whether you're within spec limits by the capability PPK. So if you're above this line at 1.33, then you're looking fine as far as the distribution of values with respect to the spec limits. You're well within the spec limits. If then the stability index is on the x-axis. So if it's a pretty unstable process, even if it might be capable but unstable. So if you look at that process, it might have some stability thing that wanders around some. And if you're in the yellow zone, you're capable but unstable and so on. The red zone is the bad zone where you're both incapable and unstable. And so looking through hundreds or thousands of processes is easy now, where it used to be a lot of pain. The question is, what changed the most? Here's some survey data where over many different years, you asked a question about their activities. Did you go camping or gamble in a casino? Or did you have a cold? You know, all these activities. And you want to know which among all these activities, and there's, I think 95 different activities, which of these made the most difference? And so you're looking for, you know, one thing you could do is go through one at a time and fit that activity by year of survey. Instead of looking at one at a time, I can look at response screening and just look at one chart to see what's changed the most. And so this is showing a chart for all 95 of those things. First, the significance in terms of the negative log of the p-value, which we call the log worth, which is adjusted for the false discovery rate. And so it takes care of some of that selection bias because you're sorting all those p-values and selecting the low p-values. And I find that renting a videotape changed the most, a video cassette tape. And of course, they became obsolete. So of course it changed. Another video cassette tape changed a lot. Collected things through recycling changed a lot. Entertained people in my home changed a lot. And here's one that's a little less significant, but big effect size, use the internet. And of course, this survey was started before there was an internet. And so it changed a lot. So the question on what changed the most was, is easy now where it used to be hard. Another question you ask about big data, where are the missing values? So here are 280 variables. Where are the missing values? Do I need to worry about them? And I can look at the Explore Missing Values report and see that, well, there are only 5 of these variables with missing values. And some of them only have one variable, one missing value, but some of them have a lot. So when I do an analysis, a multivariate analysis, I probably don't want to include the variable J because J is missing more than it is non-missing, 376 out of 452 variables. Or if I want to include J, I can go through and impute those missing values by doing that, okay? So, next question, does the data have outliers? Well, I have 387 measurements I do in this process, and I want to find out if there are outliers in there. So now we have a facility to do it in the screening menu. I can make this more or less sensitive. Let's make it more sensitive so there's fewer outliers and rescan. I can look at the nines. So often a string of 9s is used to represent a missing value. And those 9s may be real 9s, but they may be just an indicator of a missing value. And so I can, for those, I can say, well, add those 9s to missing value codes. And now the memory has changed. And now I can go back up. There's a lot of variables here and rescan. And there's fewer missing values to worry about. So exploring outliers used to be a pain. It still can be a big job, but it's a lot easier than it used to be. Now with version 15, we added another screening platform. Does the data have suspect patterns? And so here's some lab data from clinical trial. This is nicardipine lab patterns data. There's 27 laboratory results that I may want to look at. And so I invoke the new platform, Explore Missing Values. And this is going to show me, do I have a run of values? So I have the value 0.03536, but there's 7 in a row starting in row 2065. I can colorize those cells and I can look at those values, and maybe it's the last value carried forward, which may not be suspicious. In this case, it's the same person. So maybe the last value carried forward is a reasonable thing to do, but it is a rare event if you distributed these things, if you assumed random distribution for these things. Also, longest duplicated sequence. So for this variable, starting in row 2816 and also starting in row 3034, there were 4 in a row that had the same values. So if I colorize those things, there's 4 in a row there. And if I go to the next sequence, there's 4 in a row that have the same values. So that might be a symptom of cutting and pasting the same values from one place to another. So Explore Patterns is looking for those things. And there are many other things that you can look at the details on each of those 27 variables and look for symptoms of suspicious things or bad effects of the way you process the data and so on. So Explore Patterns, part of solving big problems. So pain relief. Much of our development is focused on making the flow of analyses smoother, less burdensome, less time-consuming, and less painful. Analgesics. Now, we don't always know what's painful, so we depend on feedback for what to focus on. When we get those emails that I had to respond to a prompt hundreds of times, we listen to that and we feel the pain and we fix it so that now you can broadcast into a buy group with thousands of things and broadcast the result of one dialogue rather than dialoguing many times. So sending it in made it better for everyone else because we didn't catch it the first time around. So please give us your feedback. With all the improvement we've already made, we think the process of data preparation and analysis has already become much smoother, much less interrupted, more in flow. So instead of spending your time getting over obstacles, you spend your time learning from your data, understanding your data. So we have analgesics, the big A word, and it's inside another big A word, analytics. One would wonder if they came from the same root. Of course, we don't like to abbreviate those two words. Analytics comes from the Greek analeion. I don't know how to pronounce that. But in Greek, it means to break up, release, or set free. And it's taking something complicated and breaking it up into pieces so we can understand it. And that's, of course, exactly what we do with analyzing data science. And analgesics comes from a different combination of words, and meaning without, and algesis, which is the sense of pain. So same prefix, different, a little bit different roots, and don't abbreviate those. So you'd think that all we spend, from this talk, all we spend our time on is pain relief. Well, of course, that's not true. The other two words are important too, anabolic and aphrodisiac. We care about power. Much of what we do is to give you more powerful tools for analyzing data. Much of that in JMP Pro as well as in JMP. And we hope that data makes it exciting, the thrill of discovery. the thrill of learning how to use power features in Jump. And we think it's exciting, it's an aphrodisiac. So power and excitement are also of value to us. It's not just pain relief. So what are we going to do next year? Well, big word starting with the letter B. Start with A, next is B, right? Well, next year we have Jump 16 coming, and so that's what we're going to talk about. Who knows what we're going to talk about the year after. So thank you much, and we hope you suffer very little pain in analyzing your data.
Thank you very much, John. We appreciate that. It was a fantastic talk, and having been around to witness a lot of the pain over the years, it is everything you say is absolutely true. Pain relief is an important thing for us. We did have one question that came in. I actually had a number of questions. We've answered some of them in the Q&A, but one I wanted to throw to you that came in during the talk, and that was, is there any feature that's been added over the years that is actually all three? It both has relieved pain and provided some attraction and made Jump more powerful.
Well, I think everyone's big delight is Graph Builder. It feels incredibly powerful to just drag those variables over and do a few other clicks, and you have the graph that you want, and you can change it so easily. So it's a thrill, it's a powerful feature, and it's pain relief. Used to be harder to do. So I think that's everyone's favorite thing. But of course, there's Jump is a rich product, and we're proud of everything in it. Design of experiments, all the great power involved in there, and we've tried to make that process easy as well. And so many things come to mind.
Very good. Thank you very much, John. I appreciate it.